Hi there, welcome to my channel. In this video, I am going to discuss about the solution for finding kth largest element in an array. Let's look at the problem description. We are given an integer array nums and an integer k, and we have to return the kth largest element in the given array. So we are expected to solve this problem without sorting the input array. Let's take a look at the example 1. So in the nums array has 3, 2, 1, 5, 6, 4, and we have to return the second largest element in the input array. In this case, 5 is the second largest element, so the output is 5. And in the case of example 2, there are duplicates in the input array, but if we sort this and find the fourth largest element, the 4 is the fourth largest, so the output is 4. The constraints for this problem are the value of k and the length of the input array is ranging from 1 to 100,000. The value of elements in the input array is ranging from minus 10,000 to 10,000. We are given the input array with 6 elements, which is 6, 3, 1, 5, 2, 4, and the value of k is 3. So we have to find the third largest element in this unsorted array. If the input array is in a sorted order, we can easily find third largest element by computing the index of that element. Basically, the kth largest element located at index n minus k. So in this case, n is 6, k is 3, 6 minus 3, 3. So the third largest element is at index 3 in the sorted array. So here it is 4. But we are expected to solve this problem without sorting the input array. Another approach is we can use min heap data structure to find the kth largest element. Okay, so basically we create a min heap of size k, in this case 3. We add the elements into the heap. After the heap is full, whenever we add an element to the heap, we check the incoming number with the root of the heap. So for example, here the k is 3, so we create a min heap of size 3. Okay, so we keep pushing the element into the heap until the heap is full. So here it is 3 elements. Here we have the smallest number among these 3. So the root contains the smallest number. So next we add the number 5, okay, into the heap. So whenever once the heap is full, we start comparing the incoming number 5 with the current root value. So if the incoming number is greater than the root, then we pop the root and then add the current number. So in this case 1 is removed from the heap and then 5 is added to the heap. So 1 will be removed, and once 5 is added, the smallest number will become the root of the heap. Next we add the number 2. We compare number 2 with the root of the heap. So the current number is less than the root of the heap, so there is no change in the heap. Next we add the number 4 into the heap. We compare that with the root. The incoming number is greater than the root, so we remove an element from the heap and then insert the current number. Now the 4 is at the root, and once we reach the end of input array, then finally we pop the root element. We return the value of the root element in the heap, in this case 4. So that's what I have written here. First we initialize the heap, and then we traverse the nums array, and in each iteration, if the heap size is less than k, we push the current number into the heap. Otherwise we check the top element in the heap with the current number. If the top element is less than the current number, then we pop the top element and then push the current number into the heap. We repeat this until all the elements in the input arrays are processed. Finally we return the top element of the heap. Let's look at the flowchart. Input for this procedure is nums array and value k. First we initialize the heap and then the index to 0. Then we enter the for loop. We check whether we processed all the elements in the nums array. If all elements are processed, then we break out of the loop and then assign the top element in the heap as the return value, and we return. Otherwise we check the heap size is less than k. If that is true, we push the current number into the heap and then we increment the index and process the next number. If the heap size is greater than or equal to k, then we check whether the current number is greater than the root of the heap. If that is true, we pop the element from the heap and then push the current number into the heap. Otherwise, we go ahead and process the next number. We repeat this until we process all the numbers in the input array, and finally we return the top element of the heap as the return value. Let's move on to coding. First, I create a new data type, min heap, which is an implies of int. Next, I'm going to implement the methods listed in the heap interface for this data type so that I can perform heap operations. First, I'm implementing the len method, which returns the length of the slice. Next, I'm going to implement less method, which compares the two elements at the given indexes and return the value of index I is less than the value at index j. Next, I write the swap method. It swaps the two values at index I and j. Next, I implement the method top to get the value at root node. So the length is greater than 0, then I return the value at index 0. Otherwise, I return the invalid value. Next, I write the push method to add an element into the heap. This will append the input number into the heap. Next, I implement the pop method. This will remove an element from the heap. So here I return the value of the last element in the underlying array, and then I adjust the size of the slice. Then finally I return the ret val. And I am implementing the find kth largest function. First I initialize the variable h of type min heap. Then I initialize the heap. Next I write the for loop to process the numbers in the input array. Each iteration I check the current size of the heap. If it is less than k, then I push the current number into the heap. Else, I check the root node's value with the current number. If the current number is greater than the root node's value, then I pop the root node and then I push the current number into the heap. So once all the numbers are processed, finally I pop the minimum number from the heap and return that as the kth largest value in the input array. Next I am going to run the test cases. All the tests passed. Next I am going to submit this program. Cool, this program is accepted. Next I am going to do the code walkthrough with sample input. The given input array has 6 numbers, 6, 3, 1, 5, 2, 4, and value of k is 3. So basically we have to find the third largest element in the unsorted array. So in this case 4 is the third largest element. So the output is 4. So first we initialize the heap. So the heap is empty now. Then we start processing the numbers in the input array. Okay. So in the iteration 0, we process the number 6 and we check whether the size of the heap is less than k. In this case it is true. So we push that number 6 into the heap. Heap has only one element. And in the iteration 1, we process the number 3. We check the current size of the heap, which is 1, that is less than 3. So we push the number 3 into the heap, and the 3 is the smallest number, so 3 will be in the root of the heap. The next iteration, we process the number 1. Still the heap size is less than 3, so we push the number 1 into the heap, and now the 1 will become the root of the heap because that is the smallest among these 3 numbers. Okay, and in the next iteration we process number 5. We compare 5 with the current root 1. Because 5 is greater than 1, we pop minimum element from the heap and then push number 5 into the heap. So 1 is out and 5 is in. So among these 3 numbers, 3 is the smallest, so 3 will become the root of the heap. Next we process the number 2, which is less than the root of the heap, so there is no change in the, we are not adding this number into the heap. Okay, and finally we process the number 4 and we compare this number, the number 4, with the root of the heap. So the current number is greater than the root, so we pop 3 out of the heap and add the number 4 into the heap. So among these 3 numbers, 4 is the smallest, so 4 will be in the root of the heap. Once all the numbers are processed, when we come out, we pop an element from the heap, which is 4, and return that as the third largest number in the input array, and that is an expected output. Next, I'm going to do the time and space complexity analysis for this solution. The time complexity of this solution is order of n times log k, where n is the number of elements in the input array, where k is the size of the heap. Let's take a look at this case. This input array has 6 elements and we have to find the second largest element in this input array. Time complexity of an operation in the heap of size k is log k, basically the height of the heap. So in this case, k is 2, the heap size is 2, so log 2 is 1, and we have to do 6 heap operation to process these 6 elements, so 6 times 1. The time complexity for this input is 6. So if there are n elements in the input array and we have to find the kth largest, then we have to do n heap operations on heap with height log k. So the time complexity is order of n times log k. Space complexity is order of k, where k is size of the heap. Okay, basically we have to store k number of elements in the heap. We need to allocate space for those elements. So that's why the space complexity is order of k. Thanks for watching this video. Have a great day.